Okay guys, for this video you need a couple of sheets of patty paper and you need your protractor. So we're going to be paper folding an angle bisector. Remember, a bisector is dividing a geometric figure into two equal parts. So an angle bisector is simply doing that to an angle. So it can be a line, it could be a segment or a ray, any part of a line, but it is dividing an angle into two angles that have equal measures. Anytime we do a paper folding in class, make sure that you label it just like I do and that you keep up with it with your notes. It is a good thing to refer back to when you're studying. Also, any drawings that we do need to be done so with a straight edge. So you can use the straight part of your protractor as a straight edge to draw your figures with. And usually when we use patty paper, the larger you can make your object, the easier it is to deal with. So we're going to begin by just drawing an angle. I'm using my straight edge. This angle doesn't have to be a certain size or angle measure. I'm using a pen, but you would always want to use a pencil. I'm just using a pen so it's easier for you to see, and I'm having a hard time for some reason writing on this one with that pen, so I'll just change it. Now, I always have students ask me, do I put arrows at the end or not? It doesn't make any difference. It doesn't change the angle in any way by putting arrows here or not putting them on there. Measuring an angle is the amount of rotation, so it has nothing to do with how long we make those sides of the angle. Now, the point where the two sides meet is called the vertex of the angle. We're going to name this vertex A, and remember you always use capital letters for points. So these are the sides, these rays, and that's the vertex. Now, to paper fold the angle bisector, we are going to fold one side on top of the other side. The transparency of the patty paper allows us to see this in action and see that we're on top of the other line. And you want to make sure that your fold's going to go through your vertex. So make sure you don't crease until you have it exactly where you want it, because you get to crease one time. So I had one side on top of the other. I'm going through my vertex A. So when I open up my paper, I can see my fold goes through my vertex and divides my angle into two angles of equal measure. Now you can pause here, rewind, and play that as many times to get yours done. Once you are happy with your fold line, you're going to draw over it with your straight edge and your pencil. And so I have created an angle bisector. This ray is bisecting my original angle A into two angles. Now we're going to verify that they have equal measures. Now I might be a little off because I just happen to be human just like you guys are, so you might be a little off too. But like I said, as you do this more and more, you'll get better and better. Now when measuring with your protractor, you have a little dash at the center of the bottom of your protractor just like I do. That always goes on your vertex. And then you're going to rotate your protractor so that one side of your angle is along the edge of the bottom of your protractor. So this is at point A, and then the side lines up along here so that it goes through 0 degrees. I'm going to see where does this side of that angle go through. Now it goes through two numbers, a small number and a large number, but obviously this is an acute angle, so I'm looking at the small end. So mine is at 3123 degrees. So this is a 33-degree angle. You measure yours and label yours. Now when I go to measure my other angle, I still put this center dash at A. I'm lining up the side of the angle so that that side goes through 0. And I'm looking to see where this side goes through. And you can tell I'm a little off. I'm at about 31 degrees. So Miss Hale had a little bit of human error as well. Okay, and I think my error was actually in the drawing of my fold line because my fold line is about right here, not where I drew it. So that was probably my mistake right there. Not the fold, but the drawing. Okay, so let's pretend both of those were 32 degrees and this was absolutely perfect. So in the world of video, I'm going to mark these out, mark them 32 degrees each, just to declare that these are congruent. And the way we show that in an angle is we draw arcs in each one of these angles. Now you don't draw one giant arc through both of them. Notice I drew two individual arcs to show that those are congruent to each other. So what we're going to do is we're going to place a couple of points on our angle bisector, and I'm going to label these B, C, and D. There's nothing magic about where I place them, so you can place them wherever you would like to. Now we're going to look at their distances from the sides of the angles. Now watch and listen very carefully here. To see how far B is from this side of the angle, I don't just draw any line I want to here. And we can see this in this drawing here. If I'm trying to see how far B is from segment AC, I can't use any of these lines. I have to use this green one. I have to use the one that makes the perpendicular relationship to that side. So that's what we're going to do with ours, is we're going to create some perpendicular relationships. So notice that's what I'm going to use my second sheet of patty paper for, because each corner is a 90-degree angle. Now I'm going to put the corner at the side of the angle, and I'm going to slide it over until that edge of my paper goes through point B. But notice here's the corner right here. This is where I'm saying the 90-degree angle is occurring. And so it's going through B, and I'm going to trace that line right here. That's how far point B is from this side. And so I'm going to do the same thing for C. I'm going to keep the corner at that edge, going through C, and I'm going to draw that segment right there. Again, my right angle is here at the side. I'm going to do the same thing with D, corner on the side, going through D on the edge, draw that segment. Again, here's my right angle. Now I'm going to do the same thing to the other side. So I'm going to turn my paper over just to make it a little bit easier. Remember, the edge, the corner, is going on the side of the angle. So I'm putting it here, not at B, but on the side of the angle, going through B. So here's my right angle here on the side. And I'm going to do that for C and D as well. So you should have 6 segments drawn, 2 from each point with the perpendicular angle, the 90-degree angle at the sides. So you can pause here if you need to get those 6 drawn. Now what I want to see is there a relationship between these 2 distances from each point? So if you have a ruler, you can use a ruler. If not, you can just put your second sheet of patty paper over your figure. And I'm going to trace from B, the segment going perpendicular to the side, from C, and from D. I'm just tracing those distances. Now I'm going to come around and see if they're the same as the distances on the other side. So as I place this over there, I can see it's a little off, but that's because my angles were off, if you remember. But those are the same distance. I can bring the medium one over here. Those are the same. And the long one here. Those are the same. So what I just showed is that D is the same distance from this side of the angle as it is from this side of the angle. C is the same distance from this side as it is from this side, and B is the same distance from this side as it is from this side. So notice I used what are called tick marks to show that these are the same distance. But I used 1 tick mark on each one of these, and then I went to 2 tick marks for these and 3 for these, because these distances are not the same as each other. So I would not use the same number of tick marks there. All right, so what we're going to do now is we're going to make a conjecture based on what we just learned. So number 2 on your notes tells you what a conjecture is. It says it's simply a statement that you believe to be true based on your observations. So it's not something we know to be true yet. It's just something we believe to be true. So based on what we just learned, we believe that what is true is every point on an angle bisector is the same distance from each side of the angle. So that's what we're going to write on number 3. Every point on an angle bisector is the same distance, and we have a fancy word in math for that. It's called equidistant. It's like saying equal distance, but in one single word. Equidistant is the same distance from each side of the angle. Now, this is only a conjecture. It's only something we believe to be true. So kind of like in social studies, you can have a bill become a law, but it's just a bill until it gets passed. Well, we just have a conjecture right now, and until we prove it to be true all the time, it's just a conjecture. Once we prove it to be true all the time, it will graduate and become a theorem. Now, let's look at our examples here. Using that conjecture, I can tell by the arcs here that it's telling me this angle and this angle have the same degree measure. So that tells me this ray is an angle bisector. So point D is a point on that angle bisector. So I know it's the same distance from both sides of the angle. So that tells me that DF and DE are equal measures. Or in other words, those segments are congruent. So remember, we have two ways of denoting that. So easiest problem ever, if DE equals 8 centimeters, then that means DF is also 8 centimeters. Now, number 5 and 6 throw a little bit of algebra into this geometry problem, but still, if we know DF and DE are equal, all that tells me to do is to set these things equal to each other to make equations. So for number 5, I would say 2x minus 3 equals 9. DF and DE are equal. So then I would just show my work to solve that equation, adding 3 to both sides, and then dividing by 2, I get x equals 6. That's all it asked me to do on this problem, but you could definitely check it by putting it back in to make sure that DF is 9 just like DE was. So if I put 6 in for x, 2 times 6 is 12, minus 3 is 9. So that just lets me know that's correct. Number 6, again, DE and DF are equal, so I'm going to set negative 3x plus 18 equal 2x squared. Remember, this was a linear equation. It only had one solution. This x squared makes this a quadratic, so it can have up to 2 solutions. So we practice factoring for this reason. Remember, we want all the terms on one side set equal to 0. We want to keep x squared positive, though, so we're not going to move it. We're going to move the other 2 terms over with the x squared. Don't forget to change their signs when they change sides. So that negative 3x becomes positive. That positive 18 becomes negative on the other side. I put it in standard form, x squared, x constant. So I need factors of negative 18, numbers that multiply to get negative 18, that add to get positive 3. And so those are positive 6 and negative 3. 6 times negative 3 is negative 18. 6 plus negative 3 is positive 3. Now remember, that does not mean x is 6 or x is negative 3. You have to use the zero product property, which says if these two things multiply to get 0, then at least one of them has to be 0. So either x plus 6 is 0 or x minus 3 is 0. Solving these by subtracting 6 from both sides, I get x equals negative 6. Adding 3 to both sides gives me x equals 3. Now this is all it asked for in this problem, is to find the value of x. Always make sure in geometry that you check these answers, because if you plug one of these in and it makes one of these distances 0 or a negative number, that means that can't work for this problem. So even though algebraically it would have 2 solutions, it won't always have in geometry. But both of these work in this case. If I put negative 6 in, negative 3 times negative 6 is 18. 18 plus 18 is 36. Negative 6 squared is also 36. If I put 3 in, negative 3 times 3 is negative 9. Plus 18 is 9. 3 squared is also 9. So both of these work in this problem. Okay, so just to wrap us up here, remember our angle bisector solution or conjecture is just a conjecture at this point until we prove it. It is not a theorem. It's just a conjecture. And you make conjectures outside the mathematics classroom all the time. Remember, they're just statements you believe to be true based on your observations. You will need a sheet of patty paper for number 1 on your homework. Make sure you turn in a picture of that. You are folding a 45-degree angle, which means you're going to have to start with a 90-degree angle. That does not mean you need to draw one with your protractor, though. You have a 90-degree angle at the corner of your patty paper already given to you. Also, on your homework on the back, I would suggest working numbers 8 through 13 first and then answering number 7. So save number 7 until after you work 8 through 13. Thank you.